Hi everyone, and welcome to today's webinar, Best Practices for Couchbase Deployment on Microsoft Azure. I have a few guidelines before we get started. First, all attendees are on mute, but if you have a questions during the webinar, please submit it through the Q&A box at the bottom left-hand side of your screen. We'll try our best to answer all the questions towards the end. The recordings will be sent to you in a follow-up email immediately after the session. You can download the slides at any time in the Resource Center. Plus, we have included several resource links that would be valuable to you. Just click on the green folder icon in the control panel at the very bottom of your screen. It will be very valuable for us is after the session, please complete the survey at the end of the event. It will only take a few minutes, and your valuable feedback is important to us to improve our future webinars. With that said, I'd like to introduce our speakers for today. Ben Lackey, who is the Director of Cloud Partnership at Couchbase, and Boris Baryshnikov, the Principal Program Manager at Microsoft. Thank you so much for your time today, and Ben, please take it away.
Okay, thanks. So this is Ben speaking. I'm going to hit next on the slides and talk a little bit about the agenda for today. So first off, I'll take you through a bit on the Couchbase and Microsoft Azure partnership and how we work together. Then I'm going to discuss 3 different use cases, customers today using Couchbase on Azure for their production workloads. After that, I'm going to speak about best practices a bit. So various things you should do when running Couchbase on Azure in order to have reliable, scalable, resilient deployment. After that, Boris is going to take over, and he's going to talk a bit about the offer we have on the Azure Marketplace, as well as the Azure Resource Manager, or ARM templates that underlie that, and those automate many of the best practices I'll be talking about. He's also going to touch briefly on some integration work we've done with Kubernetes, the Azure Kubernetes service, and something called the Couchbase operator, which can install in a Kubernetes cluster and help automate the running of a Couchbase cluster. After that, Boris is going to do a bit of a demo, so show you how to deploy in the marketplace, as well as through the Azure CLI. And then finally, we'll have some next steps, links to helpful resources, and time for Q&A. So let's get started. So first off, the partnership. So Couchbase is a Silver Cloud Competency Partner with Microsoft. We've been on the marketplace for a few years, since 2014. Last year at Microsoft Inspire, Microsoft's large conference for partners, Couchbase was a Partner of the Year finalist based on all the work we've done integrating with Azure. Great thing. We work really closely with the Microsoft team to develop integrations that make it easier to run on Azure. Recently, we participated in Container Hackfest, the AKS preview. We were a partner in that. We were the first ISV to use the public DNS feature in VM scale sets, and got featured in a little blog post about that, which was neat. And a variety of other features, VNet peering, Azure Stack. Most recently at Microsoft Build, we were actually one of a number of launch partners for container instances in the Azure Marketplace. Something over 10 customers run on Azure today, and some number of those are public references, a few of which I'm going to talk through in a moment. So yeah, on to use cases. So this one's kind of neat. It's a company called SyncThink, and they're in the healthcare space. They use Couchbase Mobile, which is a lightweight version of Couchbase, and that runs on Android and iOS devices and provides a local database that an application can run with on the phone and then it'll sync back asynchronously through a component running in Azure, a Couchbase component called Couchbase Sync Gateway. That manages the synchronization to Couchbase Server, the NoSQL database, also running in Azure. So SyncThink has this whole stack deployed for their application. And one of the interesting parts about working with them was the application needed to meet HIPAA standards. So we worked through a number of different requirements about data security and so forth. And this is one neat feature Azure has. The managed disks we're now using today actually encrypt the data by default. So that's one typically significant hurdle when doing these sort of integrations that Azure just made really, really easy out of the box. This deployment followed a fairly common sort of life cycle we see. These guys started out by deploying through the Azure Marketplace, sort of next, click, deploy, have a cluster kind of model. And from there, they went over to GitHub and used our ARM templates and began customizing them a bit. Sometime after that, they went even further and customized further, and today I believe use technologies like Ansible to do the deployment. And that's something we see pretty commonly is customers start with the out-of-the-box tools we have available and then over time customize them to fit their environment. Okay, another example. So Nuance has been a long-time customer of Couchbase and is in the process of moving to Azure and is beginning to use Kubernetes. So Nuance has been running Couchbase inside of AKS, the Azure Kubernetes service. And they make use of this Couchbase operator, a technology we have currently in a public beta. And that installs in the Kubernetes cluster and then manages things like node failures and resizing automatically. So pretty neat use case. Another one, also in the medical space, is BD or Becton Dickinson. And once again, they're using the mobile technology. So the lightweight mobile database running on mobile phones, synchronizing back to a cluster running, once again, in Azure and in AKS. These two are some of our very early AKS users, which is sort of exciting. Okay, so that's use cases. At this point, I'm going to speak a little bit about best practices, first talking through two reference architectures, and then digging in a little bit to the kind of three components of IaaS. Compute, storage, and networking, and what we recommend for each of those on Azure. So this diagram shows at a high level how you might deploy a multi-region Couchbase deployment. So in this, you'd have Couchbase running in two different regions, and in each of those regions would be a VM scale set, a virtual machine scale set, with a number of Couchbase nodes in it. That would be communicating using our XDCR or cross data center replication, connecting the two clusters, Couchbase clusters in each region, over the Azure backbone. Kind of drilling into that a little bit, and calling out another feature, if within a single cluster, we wanted to use another feature called multidimensional scaling, we would deploy this way. And multidimensional scaling allows you to scale different components of the Couchbase database independently. Couchbase is made up of a data service, index service, query service, search, and our new developer preview of the 5.5 version of the product also includes services for analytics and eventing. And all those can be deployed independently and scaled independently, or they can be deployed together and scaled together. It just depends on your use case and the scale. The advantage of this is different services have different performance profiles. So like data nodes might want a significant amount of disk since they are writing to disk, whereas the query workload is much more CPU and RAM intensive. So the kind of machine you use might be different depending on that use case. In this example, we have one cluster running in a single resource group in a single region, and then it's made up of 3 virtual machine scale sets. There's one running just the data service. There's a second one running both the index and the query service together, and then a third one running the search. And by breaking things up this way, as our data set slowly grows, we can slowly scale up the number of data nodes, but then we could also do more bursty things. So if we had a bunch of search or query workloads coming in, we could scale the search or query totally independently of the data. Really neat feature. Okay, so digging in a bit more. First off, talking about compute a little. So Azure has a really wide array of different kinds of virtual machines. We tend to recommend using the premium storage-backed machines. So these are machines designed to connect to Azure's high-performance SSD drives. Couchbase will run on very small machines, but your experience will probably be best with 4 or more cores. If you're just standing up a cluster to kind of poke at, you can get away with 2. Really wouldn't recommend going down to 1. It just isn't great. For most production workloads, we tend to recommend the DS14 V2 or now V3s actually. So this is a just really solid general purpose 16-core machine. It has an internal ephemeral drive that can act as a cache for the premium storage. It's just a great all-around thing. Highly recommend deploying in VM scale sets, as we were discussing in the reference architecture diagrams, as opposed to deploying single standalone VMs. And this gives you a bunch of things. It improves manageability. So one neat thing Azure does is that if a machine in a VM scale set falls over, suffers some sort of catastrophic failure, like the CPU melts down, the VM scale set will automatically reintroduce a new machine with the same drives attached. And that failure will essentially look like a reboot that took a little longer than normal, an unexpected reboot, I should say. The VM scale set also handles the distribution of nodes across fault domains and upgrade domains automatically, which is really nice because that helps give you high availability and fault tolerance. The fault domains protect against hardware failures like rack failures, top-level switches in a rack, things like that. And the upgrade domains help protect against more planned outages. So if Azure were updating something at a very low level in the hardware that required a rolling reboot across much of Azure, the UDs would help manage that to ensure that not too many nodes went down at any one time. Using the VM scale sets, we typically recommend disabling auto-scaling and instead scaling things manually when you see the need arise. And the reason for that's pretty straightforward. If, let's say, you were auto-scaling data nodes and you had a rule that maybe if CPU use went above 80%, you were going to add a new node, that rule might go off, add a new node, your cluster's already under load. The new node would come into the cluster and it would call a rebalance to shuffle data around to all the new nodes. And that already loaded cluster plus the rebalance would probably cause more load and might well trigger that event again. And you could end up in this kind of cascading situation that you just don't want. You can sidestep that by scaling yourself, still using all the features in the VM scale sets, just the trigger is a manual event. Right. So let's talk about storage a bit. So for a long time, we've recommended premium storage. So that's network attached SSD storage. There are some other options on Azure. There's standard storage, which is spinning disk backed. Typically, the performance profile of that just isn't great for an engagement database like ours. You want lower latency, is what it comes down to. It's also possible to use the ephemeral disks, and sometimes they'll outperform the premium storage, but you pay a substantial price for that. The ephemeral disks tied to the machine can't be resized because they're physical, so you lose some manageability there. They're also, as the name implies, ephemeral. So if you lose the machine, they will be no more, whereas the premium storage will stick around. And then finally, there are other neat features like the encryption I mentioned earlier that you get out of the box with the managed disks and you don't get otherwise. Using the managed disks versus storage accounts is also highly recommended. Managed disks abstracts away some of the spreading things out to get the best performance issues, and just, as it says, manages all that automatically for you. Node density is always an interesting question. P30 is a terabyte drive. That tends to be a just great all-around disk to go to. So a DS14 with a P30 attached is just a pretty good, solid general-purpose system. Your particular use case may vary a bit, but if you're just coming into something generically, that can be a good thing to start with. Right. Talking about networking. So Azure has kind of 4 different ways you can address a node. There's a public DNS, a public IP, a private DNS, and a private IP. If you configure the node with the public DNS, that'll allow things like the cross data center replication to work. It'll allow clients using the SDKs to make remote connections. So if, for instance, you want to develop from your laptop, you can build your application on your laptop and connect up to a cluster running in Azure. In order to work around some network limitations, we recommend adding the loopback to etc hosts. The templates Boris will be demonstrating automate all that, so you don't really have to worry about it. And we really recommend this approach as opposed to, say, using the VPN gateways. The gateways, there's a fair amount of setup, and then they don't typically perform that well for use cases like ours. In a distributed database like this, all the nodes expect to be able to talk to all the other nodes, so being able to make those connections directly rather than sort of bottlenecking through a gateway just leads to better performance. Similarly, we typically recommend using that public DNS instead of ExpressRoute. ExpressRoute's a solution for basically a dedicated leased line, and it can be quite performant. However, it takes a long time to configure and can be rather expensive, and it'll work. We have customers using it, but if you're just trying to get up and running quickly, the public DNS will probably be a better experience. Finally, you typically want to configure a network security group on top of the VNet that's deployed to cordon off any ports that aren't going to be used. And the ARM templates do that automatically for you, blocking everything but the Couchbase ports that the product needs to run. So that's kind of your crash course in best practices, some use cases, and a little background on the partnership. At this point, I'm going to hand over to Boris, and he's going to talk a bit about marketplace templates and actually show you this for real.
Thank you, Ben. Good afternoon, everybody. I'm getting it. I'm excited. Ben, are you in? All right. All right, so I spent a little bit of time on slides just to explain what we're going to do in our demo. And then we actually will switch into a demo itself. And I will show you how to get the cluster provisioned on Azure and different ways of looking at it, interacting with it, and potentially other ways of deployment and ways to modify it depending on what your needs are and fit your environment. So there are several questions I already saw on the Q&A window. So Ben, feel free to answer them in the chat, or we will cover them at the end of the presentation with any specifics that might be left. So with that, again, my name is Boris Baryshnikov. I'm from the Azure Compute engineering team, and I work with Ben and Couchbase as our partner to enable many of those things that Ben just covered in the slides. So the first of all, where can you get Couchbase? How can you deploy Couchbase cluster on the Azure itself? So there are a couple of entry points. One of them is the what's called Azure Marketplace. I'll show you the live page where that entry point is, and you have a couple of options in there. So one of them is you can go and get a so-called test drive, which means we will provision a cluster for you and give you the access credentials to log into the console and try it out. It will run on our capacity. It's merely meant for you to try it out without even having an Azure subscription or having anything to do with Azure. The second option is actually you are deploying it on your own Azure subscription. And there are two models, two license model in that. So one of them is hourly pricing. You're buying it directly from Microsoft in this case through the Azure Marketplace. You're paying Microsoft, and there's an hourly licensing with that. And the second model, that if you already have the license that you acquired from the Couchbase, you can run the bring your own license model, which means you're only paying for the resources that you're provisioning on Azure, and the license comes with your other interactions outside of the Azure Marketplace with Microsoft. The second way of deploying this, so the Marketplace, and that's the one I'm going to be demoing first, it's the very, very easy way of getting the cluster up and running in less than 10 minutes. And then the second piece actually might be more relevant for production. So I'll show you a couple of tricks, what you can learn from the Marketplace deployment, from the UI deployment, and then how to look at that same or similar deployment using Azure Command Line Interface. So Azure uses technology called Azure Resource Manager, and it's unfortunately, I guess, abbreviated as ARM, which obviously confuses a lot of people. But ARM in this case refers to the Azure Resource Manager template that helps you configure the environment, configure the Couchbase cluster as you're deploying it on Azure, and then fit it to your configuration. So Ben listed multiple options, multiple best practices, and multiple choices you can make. We make a lot of those choices for you in the templates we provide by providing defaults for them. But let's say your environment might be different. You might have a different requirements in terms of how you place nodes, where you place them, and what sizes they are. All of those things you can control through the template deployment. Again, that is typically the way we see people use the Marketplace offer. So people started as a proof of concept from the Marketplace, then they look at the template that got generated from it, and then they finally go into the more fine-tuned version of it using the template they have the customers maintain themselves. So one other thing that I'm not planning to demo, but there will be a link in the resources that will be sent at the end of this presentation, is running Couchbase on top of Azure Container Services, AKS. AKS used to stand for Azure Kubernetes Service. And this is the managed service that allows you to run the Kubernetes cluster. So what happens in this case, you will be able to deploy AKS cluster. It's a managed Kubernetes cluster on Azure. And then on top of that cluster, you can deploy two things, so-called Couchbase Aggregator, that does the automation of all the admin tasks, and then deploys the bits, the Couchbase bits, on top of the Kubernetes cluster. And then the Couchbase itself, as you deploy the Couchbase cluster on top of that construct, you will have a running Couchbase cluster on top of AKS, which means you'll have a Couchbase cluster running in the managed AKS infra that runs on Azure itself. So again, from the endpoint, from the data endpoint view, it's the same as any standalone cluster running on top of the either virtual machines or virtual machine scale sets. But in this case, it will be running on top of the AKS. Again, I'm not planning to demo this particular part, but this is something that if you're interested in doing, there's a walkthrough in the GitHub that is available to you to do it yourself. Now, with that, let me switch to the demo itself. I'm going to start with the screen share. And once you see my screen, I should be able to show things where you can start. So I typically, me personally, I usually start with a portal.azure.com. So portal.azure.com will take you to a place where if you already have an account with Microsoft and you already have an Azure subscription, so this will log you into the Azure portal. If you never had an Azure subscription and you're trying it out, you can start with azure.com/free. So this will get you to the page where you can get a free trial subscription. And then free trial typically gives you some number of resources, $200 for 1 month, and then there's some number of services for a year free, and then there are 25 services that are always free. The one thing you should know about the Azure free account is it gives you only 10 cores to begin with. That's a limit of the free account. You can extend that amount. You can raise it higher if you add a credit card to your account. It basically validates that you're actually a legitimate user as opposed to the person trying to, fool the system by creating lots of free accounts. You will still keep your credits. You can just burn them a little faster if you have more cores. The reason I'm mentioning this, the clusters like Couchbase and what we'll see in the marketplace case, they typically require multiple machines. And as Ben was pointing out, you would probably want to run with 4 core machines. So if you're deploying 5 machines, 4 cores each, you're probably looking at the 20 cores requirement of the core necessary for you to deploy this cluster. Again, you can go with the smaller machines, with the core machines, and fit them in the free trial. But if you want something more realistic, then you probably want to increase the quota right away. Again, keep that in mind if you're running with a free account. If you already have an Azure subscription and you have access to something, then you should be able to just log into the Azure portal and use it here. Again, the second step, so once you have an Azure subscription, is to actually locate the Couchbase itself. Again, 2 ways of doing this. So one is you can search for Azure Marketplace Couchbase. This will give you a few links, and your favorite agent probably will point you to one of the top links. So in this case, it's actually the top link in this case. And what I will see in here is this is the marketplace offer. And there are 2 options that I mentioned before when I showed the slide. So one is the test drive, something that we deploy on our infrastructure, lets you use it without having to have any Azure subscription. Then the second one is a get it now, which will deploy it into your own Azure subscription. So the second option is actually once you are in the portal, you can click on create resource. This is what I'm going to use, and you will type Couchbase here. And if you hit enter, you will see all Couchbase offers that are available in the marketplace. And I'm going to pick the Couchbase Enterprise Bring Your Own License offer in this case. And I will show you how easy it is to deploy this just with your own subscription. So you hit the create button, and you need to provide a certain number of parameters. In this case, the Azure username. I'm going to put my name in it and the password. So this password has some complexity requirements. And then there's a certain number of limits on the admin username. So there's certain usernames that are restricted, such as admin, or it follows the rules that are not letting you create users in the regular VMs. And those 2 credentials that I just provided, they will be used for both for SSH access to the VMs, and they will be used for the Couchbase login in the web console. Again, you can modify those things if you are using your own templates, but for the marketplace deployment, we're using it in this way. So I'm going to give it a resource group name. So I'm going to call it Couchbase 3, and I'm going to pick the region that I know that I have not deployed anything in. So let's say it's Japan East. The reason I'm picking the remote region in this particular case is because I'm trying to avoid the problem of running out of cores in any given region. There's one way I will show you how you can check what you have available in a particular region. So I hit OK on this. And then the next step is actually merely allowing you to pick what the node size, what is your default virtual machine size, how many nodes are there, and some other parameters. Again, I'm going to just use all the defaults, not change anything. And I'm going to hit OK. The next step is the validation. So what validation does, it verifies that the parameters you provided actually are valid for a particular region. And the second step of the validation actually queries that the environment has sufficient capacity for you to deploy this particular offer. So in this case, I'm asking for 20 cores, and the validation just checked that I have those 20 cores available. If you run this in the free trial, you will probably get the red exclamation mark saying that you're requesting 20 cores, but you only have 10 available. Now, one trick I want to highlight in here, which is useful for the future development. So there's a button highlighted here. It's called download next to the download template in the parameters. And if I click on this button, it will actually show me the Azure Resource Manager template that got generated as a result of your choices with all the parameters selected. Again, even though this is human readable, typically you generate those deployments and then you just automate it and reuse it. And not something that you craft from scratch by hand. So you can use this template, you can download it and save it, or you can modify it right here directly to make any changes. And then after you do so, you can continue with the deployment. So I hit OK, and this lets me read and agree to the terms of both Microsoft and Couchbase. And once I hit create, that submits the deployment to the platform. Now, because deployment typically takes anywhere between 4 to 6 minutes, we're deploying the virtual machines in virtual machine scale sets. And then we're deploying bits themselves of the Couchbase on top of those machines and the configuring cluster. And in about 5 minutes, we'll have cluster up and running. Now, instead, I have a couple of clusters already running in here, and I'm just going to show one of them. So in this case, I have a cluster that I deployed yesterday. And if I click on the deployments button right in here, you will see that one of them, the top one, so it took about 5 minutes to deploy. And the reason I'm going in this place, I actually want to find the URL where to connect to this cluster. So upon successful deployment, you will have outputs in here, and the server admin URL will be the automatically generated URL to your environment. So I'm going to just copy that, open a new tab window, and paste it in here. So this lets me log in with the credentials I just provided. So I use Boris and my favorite demo password. So I'm going to just sign into this. And what you're seeing here is now you're interacting with the Couchbase web console. And you can look at how many servers you have. So in this particular case, I deployed 5. There's no data on those servers. And what I'm going to do to make it a little bit more realistic, so I'm click on buckets and there's no buckets. I'm going to click into samples, and let's say I'm going to load the travel sample in here. So what you will see happening is that the data from the samples starting to get loaded, and you see a little bit of load on the machines. And if I click on any one of those individual machines, I'll start seeing some activity happening. And again, you can look in more details what are particular things in here going on. Again, going back to the dashboard, I can also go to the query window. And because I'm loading the travel sample, let's say I want to find all the airports in the United States. I'm going to click explain. This will show me the valid plan. Usually the validates that don't have any typos in this query. And then if I click execute, actually most likely we'll get an error. I did get a successful result. So sometimes if you have a large data set, then you will see that the result exceeds allowed limit, and then you just need to put the limit of a certain kind. Again, this is an example interacting of the Couchbase itself. And the point I'm trying to highlight in here, so in just about 5 minutes, you can have an active cluster with which you can play running on top of Azure. Now, one other thing I want to demonstrate with this particular cluster is I want to scale it. So remember that we only had 5 servers in there, and let's say you have a peak load. It's whatever high active time, sales time, Black Friday time, something like this. And what Ben was highlighting is that you can do this manually. And the construct we're using for deploying it in here is so-called VM scale set. So in VM scale sets is a collection of identical VMs. And the beauty of it is that you just create the resource called VM scale set, and you declare how many instances you want in that particular service. And in this case, I have 5 of them already deployed. That's what was my default choice in the marketplace. So if I click on scale and say, I want, instead of 5, I want to have 7 VMs, and I'm going to change it in here. I don't enable auto scale. That's a best practice. Do not have auto scale enabled. This is stateful workload. And I'm going to hit save. So hitting save in this case causes API call to the Azure Resource Manager from, again, in this case, the portal UI. And that allows the platform to allocate 2 more identical VMs of this kind. And as soon as that allocation starts, you will see how Couchbase actually reacts on top of this as nodes are getting added. Now, while this is happening, so one other thing I want to point out is, let's say you started with the portal UI, you did the marketplace deployment, you looked at it, and now you want to actually do some kind of modification. So the next step is to show you how to deploy using the CLI. So one probably the easiest way to do so is to open the Cloud Shell. The Cloud Shell, that little icon you see on top of the window in here, and it runs in any browser. And in my case, it opens the Bash shell. You have a choice in here, work with either Bash or PowerShell. Again, I'm working with Bash. And that allows me to open a terminal window that is already connected to my Azure subscription. So if I do AZ account show, you will see that I already have a subscription that I logged into. So it's because I'm already logged in the portal, so I can translate that context directly into that place. Now, what do I do to deploy from the command line? Again, in the resource links, you will receive, there's a link to the Couchbase GitHub, and one of them is the Azure Resource Manager Couchbase. And Ben here has information of how to deploy it using the command line. And probably the easiest one of them is to use the simple. So one thing that you will do in here, you will just do the git clone, right? So you copy that, go back to your terminal window, and then you just do git clone and put that URL. So that will pull that repo back on your machine. And then what I'm going to do, I'm just going to switch into that directory to see what's available in there. Not easy, so it's CD Azure. Again, going into simple case, you will see that there are two files in here. So we're going to do the deploy sh, which is the script that does the deployment. And you see a couple of things in here. So it creates the resource group and then runs the deployment using the file in here. Now, because I actually want to show you how the provisioning happening. So let's go back and take a look at our auto scale option. So in the auto scale case, you'll see that we have two more new servers created. And if I go back to the Couchbase, at some point, we'll start seeing those 2 servers added in here. So once the Couchbase bits are added and the Couchbase cluster itself recognizes the 2 new servers are available, the rebalancing will start. So all I'm trying to look at right now is what happens in this case. During that rebalancing, the cluster remains available, and you can continue running queries to actually get your information. So that's kind of one of the cool things you can observe with that auto scaling. So this is an example of what's happening in here. So nodes are already recognized, and once the rebalance happens between those 2 nodes, you will have all your data spread between different nodes. Again, Couchbase automatically recognizes new servers that added to VM scale sets, and it will be able to place data on top of those additional machines. And the same thing happens with the failover. So if one of those nodes goes down because of unplanned maintenance or because of failures of some sort, then the virtual machine scale set as a feature of Azure will let you replace that machine, and then that machine will be rebalanced as far as data goes. Again, let's go back to our console window. So in this case, one thing I mentioned at the very beginning, how can you tell that you have enough capacity? So going back to full screen, one of the commands that are available in the CLI, which is already installed in here, is the AZE-VM list usage. And you need to specify a location. So one of the locations I have been using is West US and West US 2, actually. And what you see in here is that this is your quotas. And in my case, I observed the reason I actually picked Japan as opposed to West US 2 is I'm already at 77 cores out of 100 availables in this particular region. So if I started to deploy additional machines into this region, I most likely will run out of capacity in this region. Again, these are all default quotas for me. And in case of the free tier, free trial, you will have only 10 in this number. And you can submit the request through support in here to increase your quota. That's how it's going to work. All right, so back to the command line deployment before we complete this demo. What you saw in here, so there's deployment script that allows you to create the resource group. So I'm just going to go AZ group create, and I'm going to call it Couchbase CLI delete 3, and I'm going to, again, place it in Japan East. So group creation is merely a container where all the resources are. And then the second command is actually deployment itself. So it's CAZ group deployment create. It references the template file that we have here in the local directory, the one that I got through git clone, and it has a parameters file. So I'm going to copy this into the buffer, and I'm going to show you the parameters files. So main template parameters files. Now, one thing I want to highlight, and actually this is something that you should not do. We use that in the sample. We did put the username and admin password in GitHub. This is a big no-no. Please don't do that. So you typically keep this in the file that is never checked into the GitHub. So because if you start deploying this off the GitHub, people do port scan, people do try to find things, name, password, and as soon as they find the port open in Couchbase, they will use the default password they found elsewhere, and they will attempt to log in. Again, keep that in mind. So you typically provide it as a secure parameter in the command line. We're using it for simplicity of a demo here, clear text. But then the command itself, so I'm creating deployment. I'm referencing the file. I'm referencing the group that I just created. So this is Azure Couchbase CLI delete 3, and I'm saying no wait. No wait means that this CLI will merely submit the deployment after validation. So again, the validation happens right now to verify that I have enough capacity. And once that validation completes, the deployment ongoing. So going back to our window, if I open my resource groups, so you will see that the Couchbase CLI delete 3, the group that I just created, is exactly where the source is starting to be created. So this is the deployment we just submitted. Now, if I go back to resource groups, and remember we deployed the Couchbase at the very beginning of this demo, and you see that 2 deployments have succeeded. In this case, it took about 5 minutes to deploy the cluster. And again, if I look at the outputs of that deployment, you will see the URL of the cluster where I can go and log in with the credential I have provided. So with that, this is the short demo that I want to complete. And let me go back to the slides. So let's see, I need to figure out how to pass back my sharing. All right. So, and with that, let me pass the microphone back to Ben as far as the next step go.
Cool. Thanks, Boris. Yeah. So as far as next steps, we have a bunch of resources that should be shared with all the attendees, and then we'll follow up with some other links too. There's a dedicated partner page, couchbase.com/partners/Microsoft, that has a bunch of links to other things. Boris, of course, showed you the Azure Marketplace. There's documentation that walks through how to deploy in the marketplace, as well as best practices. And then, of course, we talked about the ARM templates. So we'll share all that. While we've been talking, a bunch of interesting questions have come in. So sort of step through and try to answer some of those in the time we have left. So one of the questions, can Couchbase integrate with Azure Data Lake storage? If yes, what are best practices and use case? So yeah, you can integrate Couchbase with Azure Data Lake. The best way to probably go about that is Data Lake supports Spark, and Couchbase provides a Spark connector that can pull data in or out of Couchbase through Spark. So we'd probably suggest plumbing things together that way. And we have a number of customers doing variations on that. As far as use case, typically that's for like offline batch analytics kind of stuff. So Couchbase might be running and have some app running on a web, mobile, or IoT device with millions of users connected to it, doing like millisecond response times. And through that Spark connector over to Data Lake, you then do things like roll-up reporting. So end of month, let's figure out what user engagement is, things like that. Next question, is this active-active? And I believe that's referring back to the reference architecture we showed for cross-data center replication. And the answer with so many things is it depends. So yes, you can deploy in an active-active scenario. Other customers deploy in an active-passive scenario. It just depends on what you want with your application. Next question, does that offer 4 nines SLAs? So Couchbase, we're a software vendor. And by and large, we don't guarantee SLAs. And instead, we provide the software. And then depending on how you run it, you'll get a different SLA. Oh, go ahead.
And I can answer that question as well. So we do provide 4 9.5 SLA for the clusters that have more than 2 VMs, 2 or more VMs in the availability set. So that's a standard Azure VM SLA. So short answer to the infrastructure is yes, we do provide at least that much SLA. If you're using single machine, the SLA is a 3 nines. So that's a standard Azure SLA. So from that point of view, we do. Now, as Ben was pointing out, there's a software and things that might get broken high level in the stack. That's a more subtle question. But SLA wise, as far as the infra, you have that number available to you.
And that's a really good point, Boris. So yeah, the infrastructure underlying can certainly provide that kind of SLA, and then the software properly configured can, of course, provide it. Couchbase also recently launched managed service in conjunction with Rackspace, and they'll run and configure your cluster for you and help guarantee those sorts of uptimes. Next question, how do we address persistent storage in containers? That's an interesting one. So running Couchbase, the operator inside of AKS, currently the operator's in kind of public beta, and it's using empty DIRs for storage. So basically the containers own storage, and that's volatile ephemeral storage. It's non-persistent. We are working towards adding persistent volumes, and then it'll be persistent. We're expecting that shortly, and as one would imagine, it's a common ask. Cool. Next up, what underlying OSs are supported? And I suspect this question is in relation to the Azure Resource Manager templates that are deploying IaaS infrastructure as a service. What Boris demoed both in the marketplace and on GitHub is using an Ubuntu 14 image. That said, Couchbase supports a wide variety of OSs. We have customers running on Azure in Ubuntu, various versions of Red Hat, various versions of Windows. We even support Oracle Linux, believe it or not. So there are all sorts of OSs to choose from. The templates, as they're provided, target Ubuntu, but it's possible to customize those to work with non-Debian related OSs, RHEL derivatives, all sorts of things.
And I'm going to add to this. So Azure has 8 what's called endorsed distributions, which means we partner with the distro vendor to ensure testing of a particular distro on Azure. And as Ben mentioned, there's a whole variety of them. Red Hat, Oracle, CentOS. I mean, CoreOS is now part of Red Hat, and Ubuntu, obviously, and SUSE. The way you change these things, so this is where your modification of the Azure Resource Manager template becomes handy. There's a parameter in the VM scale set that's called image reference. So that image references a particular what's called URN that refers to an image of a given OS. So as long as Couchbase cluster runs on top of that OS and that OS is available in Azure, then you are fully supported from the pure deployment and it runs on point of view. And then you can run on whatever is your standard OS choice in the company. Ben, back to you.
Oh, cool. No, that's a really good summary. Yeah, next up. Within AKS, is it a managed service? Does Couchbase perform all the maintenance? So AKS itself is a managed service, and Microsoft manages quite a bit of what goes on in there. At a slightly higher level, the operator also attempts to manage many things. So it'll recover from a wide variety of failures. It'll handle scaling. As I mentioned, it's currently in a beta. For the GA version, we plan to handle things like upgrades automatically. That said, it's not fully automated. So a fully automated managed service would also have an operations team behind it who could fix things that sort of fall outside of the bounds of the automation. If you're deploying in your own AKS cluster, that does not exist. So if you want a fully managed service, we do offer that as well. Is there anything you want to add there as far as?
Yeah, I guess maybe one highlight, and this is just a reiteration of your point. So what we demoed, and even if you deploy on top of AKS, it's not a managed service. It's the service that you deploy and own. We do provide a lot of automation, a lot of help for you to not manage pieces of it, but it's still not a managed service. So that's just, as long as you understand that or realize that difference, that sort of becomes easier to say, like, who is responsible for scaling your cluster? It's you in this case. It's not a managed service. You can put a lot of things that would let you automatically scale things, but that's not necessarily how you want to let it run without anybody looking after it. So that's probably the only addition I'll do in here.
Okay, cool. Next up, is there MFA support for access, multi-factor authentication, I'm assuming? I guess it depends which we're talking about. So in order to get into Azure and the portal and all, that goes through Microsoft's own authentication, tied to Azure AD and so forth.
Go ahead. To this. So it's exactly as you're saying. So there's a number of entry points. To enter Azure, you can enable MFA. So MFA is enabled at your identity provider. It could be Microsoft account. It could be your corporate Azure Active Directory. Just like Microsoft has two-factor authentication enabled for our own internal use. And then you can have a third-party provider like Okta that will do the second-factor authentication for you, which you can hook up into Azure AD. This is to get into the Azure itself and do things as far as deployment resources or changing resources. So the next step, and then I'll pass it to you after this, can I do MFA to VMs themselves? So in the case we're deploying right now, the answer is no. We're just using the username and password. You can use username and SSH key, which is the best practice. Or you can use what's called managed service identity, which is in preview. And again, the templates do not make use of that feature, but it's an ability for you to set up MFA on the VMs themselves. And now, Ben, back to you as far as the database endpoint access. I'm assuming that's different.
Yeah, and once again, it varies. You saw in the demo, Boris used username and password authentication to access the dashboard. Similarly, there are various authentication and authorization mechanisms to access the database via the SDK. And then the mobile device stuff, it kind of works in its own way as well. So you have Couchbase Lite authenticating up to the sync gateway, which is in turn connected to a Couchbase bucket on Couchbase server. So next up, is this 5-node cluster like a Cassandra ring? A question near and dear to my heart. Yeah, sort of. So the analogy here, a Cassandra cluster would be analogous to a Couchbase deployment. A Cassandra data center would be analogous to a Couchbase cluster. And then within that, a Cassandra rack would be analogous to a Couchbase server group. And then the easy one is nodes are nodes. So yeah, there are certain similarities in these distributed systems, and while people may call things slightly different things, there are fundamental solutions that just keep popping up again and again. Cool. How is backup addressed? So Couchbase has a backup utility that basically you point at the cluster and you say, I would like a backup, and it writes the backup out. Many of our customers run that as recurring scheduled job, and it also supports differential backups, which is kind of cool. So typically you'd run that, point it at the cluster, and then have it write to some sort of cheap, inexpensive storage. You would not have it write to premium storage because there's no good reason to do that. Next one. Boris sort of addressed this, but does the cluster go down when rebalance happens? No, not at all. So this database is designed to be an always-on, very, very resilient to failure kind of thing. So really any sort of operations activity can be performed without bringing the database down. Rebalance is one of the lighter weight ones, but it's possible to upgrade an entire cluster, go around, drop a node out, upgrade that node to a new version, reintroduce it into the cluster, and sort of go around and move to new versions of the database without bringing the database as a whole down. Numerous other activities like that.
And it's something that I maybe did not demo clear enough. So when I hit the balance button, I could have flipped into a query window and just run that same query, and I would have gotten the same result while the rebalance was happening. So you can try it out yourself. So that's one of the things you can try out.
Cool. And looks like we've got one last question. Where can I get a recording? So I believe once the webinar ends, all attendees are going to get an email with a recording and some links and things. And I believe this will also be saved for posterity if you would like to share it with any of your colleagues.
I think we're right about the time, so.
Well, that worked out well. Thanks so much for attending, and thank you, Boris, for helping out.
Thank you, Ben.
Thank you very much, guys, for a great presentation. As Ben mentioned, you will receive an email after this call, which has a recording of this session. Plus, in the resource tab, there are several areas by which you can learn more, one of which is on the Couchbase page for the feature partner for Microsoft Azure, and that would take you to the marketplace and also to the GitHubs that are noted in the resource. So once again, thank you for joining today's webinar. If you can take a few minutes to answer the survey, it is very helpful for us as we use this, and it guides us to make our future webinars better. Thanks again, and have a great day.